Hello everybody, welcome to NEET Simplified. Today I am here with another episode of clearing another confusing topic in the plant families, the world's largest plant family. Here we have the Asteraceae. It is also called as Compositae, and here we are going to simplify this entire plant family so that you can be NEET ready and prepare very easily for your examinations. So here we go. Let's understand about Asteraceae. And also, let me tell you one simple thing over here. Yes, this is the world's largest plant family. We understood that. And what are all the flowers which we see? We have the famous sunflower. Whenever we remember or recall about Asteraceae, we always remember it as the sunflower family. Yes, and also let me tell you that we have these beautiful flowers included in this family which we find in every celebration. Let me know in the comment section the flowers which we use, the festival flowers which we use regularly in every house which are belonging to Asteraceae. Yes, and now as I told you, the sunflower family, we all get fascinated with this sunflower for its special property, isn't it? It follows the sun's movement. What is that property called as? Let me know in the comments as well. And very quickly, let's begin this discussion. Here, let me tell you about the flower, the sunflower. Whenever I ask you this to get me a sunflower, we have the sunflower brought to us, isn't it? Now we call it as a flower, but is it really a flower? No, it is an inflorescence. It's an inflorescence containing two different types of little flowers which are called as florets arranged on it. And what is that inflorescence called as? We call that as head or capitulum. Head or capitulum. This is the inflorescence, and on which we have two different types of tiny florets. The ray florets which you are seeing over here, this beautiful sunray-like flowers, or the florets, the tiny flowers, and the disc florets which are arranged in the center. Right? So on the center of this head or capitulum, we find the disc florets arranged, and on the periphery, we find the ray florets. And this is how the front view of a sunflower looks like. And here you can see the side view. Right? Now, when you look at the side view, you're finding green colored appendages attached to it, isn't it? Now, these are not the sepals. People get confused that these are sepals, but that's not true. These are bracts. Now, how are these bracts present? We find a whorl of bracts surrounding the inflorescence, and that whorl is called as an involucre of bracts. As you can see, around the inflorescence, we have these bracts surrounding it. Right? Now, let's understand in detail about the head or capitulum and also about the ray florets and disc florets. So, let's go ahead. We have seen the front view and also the side view, isn't it? Now, if you take the section of this inflorescence, here you're finding the ray florets. Yes, here let me show you the disc florets as well. Now, here you're finding the disc floret, right? Now, this is the disc floret. The involucre of bracts, you're seeing the arrangement of the whorl of bracts around the inflorescence, and here all this arrangement is present on the seat which is called as the thalamus or receptacle. So this is the seat on which all these florets are arranged in a beautiful manner. Now let's understand about each of this disc floret and also the ray florets. Now let's go ahead. So here, now as we have seen the section, that was not completely clear, or it is a little clumsy to understand, isn't it? Now here we have an exclusive hand-drawn diagram for you to understand the inflorescence very easily. Now these hand-drawn diagrams, you will find it in only NEET Simplified. No other NEET zone does this. So don't forget to subscribe to us. So here we are with the inflorescence, which is called as head or capitulum, and this is the thalamus or the receptacle, the seat on which we find the florets arranged. Yes, and there is a specific manner in which these are arranged. How is that? We all know that in the center we have the disc florets, isn't it? So we have seen that there are arranged in the center, the disc florets, and also the special thing is that the young or the immature florets are all arranged in the center, whereas on the peripheries you will find the old or mature florets, right? So the disc florets are arranged in a specific manner. Here you are seeing the young florets at the center and the old florets at the periphery, and the ray florets are also arranged on the periphery, which is clearly evident when you look at the sunflower, isn't it? Now let me ask you one simple question. Now that I have told you that there is a specific arrangement of young and old florets, so let me know in the comments whether the ray florets are younger or older as they are arranged in the periphery, right? So don't forget to let me know. And now let's understand about each of this clearly. But before we go ahead, we understood that these ray florets are sun ray like, isn't it? They are looking like beautiful shining rays, and also they are ligulate in shape. They resemble the shape of the tongue, so it is called as the ligulate shape. Now coming to the disc florets, we are very clearly finding that they are tubular, isn't it? So they are tubular in shape, and the ray florets are ligulate in shape. That is something to remember for you, right? Now let's go ahead and find out the details about the ray and disc florets very clearly in the flower under the microscope, right? So this is the cross section which we have seen earlier, right? So here you're finding the disc floret, and these are the ray florets. Here you're finding the bracts as well, right? So this is the involucre of bracts which we have seen. Now let's clearly find out the details by isolating each of them under the microscope. This is the disc floret. We have isolated the disc floret, right? Under the microscope, we find the bracts over here. So disc florets are bractate, and you also can see the calyx here as well. So these ones are the calyx. Here also you can see, and here are the petals. There's 1, 2, 3, 4th and 5th petals on the other side. Here you're finding the anthers as well, right? So these are the anthers. This is style and the stigma part over here, right? Now when we remove the bracts, you are finding the ovary over here, right? So that's about the disc floret. Now coming to the ray floret, here we have removed the bract so that you can clearly find the ovary here as well, and you're finding the petals, the beautiful ligulate sunray like petals, and here as well you're finding the calyx. Now this is how the flower or the sunflower with the disc and ray florets looks like. Now with this details, we are definitely not going to remember anything, right? So we have a beautiful diagrammatic representation of each of the disc and ray floret. Let's understand that. We'll correlate that with the floral diagram and simplify everything. Yes, now let's go to the diagrammatic representation of the first one, which we are going to cover is the disc floret. Now here in the disc floret, as you have seen just now, this was there in the sunflower. On the head, on the inflorescence, you are finding the disc floret this way, right? Now let's understand each and every part of this disc floret. Now it is nothing but a tiny flower, isn't it? So it's going to have all the floral organs, beginning with the calyx, corolla, androecium and gynoecium. So to begin with, the calyx. The calyx here, you can see that it is hairy or fibrous in nature, right? So it is modified. The calyx is not the general green thing which you find, like green sepals which you find in all the other flowers. We're not going to find it here. It is modified into hairy or fibrous structure, and this is evident in the dandelions which belong to the Asteraceae. When you look at the dandelions and you blow, you will find some things, they are blowing or flowing away from you, isn't it? So those are nothing but the pappus or calyx, which is found only and only in the Asteraceae family, right? So this hairy pappus is found in case of the sepals, right? So the calyx is modified to pappus. Now coming to corolla or petals, they are 5 in number. So you can see that there is 1, 2 and 3. Here also we can see 4th and 5th on the other side, right? So these are what? These are gamopetalous. They are fused with each other, isn't it? So they are gamopetalous, Right. Now you can see also that they are gamopetalous and forming a tube-like structure. That's why the tubular nature as well. Now coming to the next part, the andrecium. We have seen the filaments over here, isn't it? The filaments and the anthers are present here. Now the filaments, you can see there is a specific property here for which you have to observe. The filaments are fused with the petals. Here we have enlarged the image. You can see that the filaments are attached to the petals, and this property is called as the epipetalous nature, right? So this is the epipetalous nature here, which you are seeing clearly. Now coming to the anthers, these are bilobed and dithecous. And one more important thing here is that the anthers are all fused, isn't it? So this fusion or this condition is called as the syngenesious condition. Right, so syngenesious condition of the anthers is what you are seeing here. So the anthers are syngenesious and the filaments are epipetalous. Now we can represent that in the floral formula also. We have to represent that definitely. How will we do that? Corolla, we have 5 in number, gamopetalous, and andrecium also 5 in number. You can see 1, 2 and 3 filaments or 3 stamens over here, and 4th and 5th on the other side, and they are fused. Why? Because of the syngenesious condition, we represent the fusion over here, and also epipetalous nature, where the filaments of the stamen are fused with the petals. So we represent the epipetalous nature also in the floral diagram. Right, now coming to the gynoecium, we have an inferior ovary in Asteraceae. Right? Why inferior? Now look at the ovary. You can see that the remaining parts of the flower are appearing to arise from above the ovary, isn't it? So that's why we call this as an inferior ovary, and ovary has got 2 carpels, hence it is bicarpellary. This is bicarpellary. Clearly you can see that they are fused, the carpels are fused, hence syncarpus. Whereas there's only one locule, so bicarpellary, unilocular, syncarpus ovary, right? There is a single ovule with a basal placentation. Hence, that's also to be remembered. Single ovule with a basal placentation. Now, so that's about our disc floret in case of the Asteraceae or in case of the sunflower, right? Now, let's move ahead and understand about the floral diagram also. Now that we understood that parts very clearly by looking at the image or which we got through the microscope, and we have decoded the diagrammatic way as well. Now let's correlate with the floral diagram also. Now the flowers are bractate. We have seen the bracts as well in the flower, isn't it? So the flowers are bractate. You can see the presence of the bract in the floral diagram. Calyx is in the form of pappus, right? And also remember, these are actinomorphic flowers. The flowers are actinomorphic. That means the flower can be, or the floret is actinomorphic. It can be cut into 2 equal halves in more than one plane. Like it can be cut this way. We have another way, right? So then more than one plane, we are able to cut this floret into 2 equal halves, right? So it is actinomorphic. It is bisexual. There is the presence of andrecium and gynoecium. Hence, they are bisexual. Calyx in the form of pappus. The white hairy structure, which you can see, these are the hairy structures resembling the pappus in the floral diagram, right? And then coming to corolla, here clearly you are seeing the fusion, isn't it? Indicating the gamopetalous nature. So we will represent that as well in the floral diagram. Gamopetalous nature, we represent it with the brackets, and andrecium, the stamens are 5 in number, and they are syngenesious, isn't it? So we are representing it with the brackets that they are syngenesious, and also we are representing the epipetalous condition with this link between C and A. That is, there is attachment or fusion of the filaments with the petals, right? And coming to the gynoecium, we all know that it is an inferior ovary, so we represent it with the line above G, and also we know that it is a bicarpellary syncarpus ovary, isn't it? There are 2 carpels and it is syncarpus. That is what we are going to represent it. So here we are representing the floral formula as well, clearly correlating with the diagram. Now representing the floral formula becomes easy only when you understand the diagram. So I hope we have simplified it with the petals image, the microscope image, and then we have diagrammatic representation, and also now we have the floral diagram. So with this, the disc floret is clear, right? Now that it's clear, let's move to the ray floret now. So here, as you have seen already, we have the ovary over here. We have removed the bract so that you can clearly see the ovary, and this is the petals, isn't it? Right. Now, let's understand here as well. This is not clear, it is clumsy when you look at the picture directly, or when you look at the ray floret, when you take it in your hand, you do not really understand what are the parts inside, isn't it? So let's make it again in a diagrammatic way. Now here we have got bracts, which we have removed here so that you can see the ovary, right? The florets are bractate, and then coming to the calyx again, it's in the pappus form. So here we have got the calyx as well, which we have represented previously, the hairy pappus or the fibrous pappus. And why is that so? This is helping in the dehiscence, in the seed dispersal. These are helpful. So that's why the modification is present as pappus, right? Now coming to the calyx, we have it in the pappus form. Now petals, the range is between 3 to 5 in number usually, and they are gamopetalous. Just like disc floret, they are gamopetalous, but the shape differs. They were tubular, they're forming a tube shape, and here these are in the sunray-like or a tongue-like shape, the ligulate shape, which we call it as. And then coming to the anthers, now here something to remember, there is no androecium. Androecium is absent. Hence, the flowers are female flowers containing only the gynoecium. Now coming to the gynoecium ovary, which is seen here, right? So the ovary is an inferior ovary again, just like in the disc floret. We can have the same clear understanding of that as well. Ovary, which is bicarpellary and syncarpous. Right? You have a bicarpellary syncarpous ovary with an ovule in a basal placentation, right? And coming to the style, you can see it here, and also the stigma. This stigma is called as bifid stigma. Yes, and here in this case of ray floret, we have only and only cross pollination that can be done because of the absence of androecium. Whereas if you go to the disc floret, we have got two different mechanisms in which the pollination can happen. Let's find out that. In case of the disc floret, we have got a bifid stigma here as well. Right? Now, when you look at the stigma and the anthers, isn't it? They are present at different positions. They are present at different levels by which hercogamy happens. The cross-pollination is always promoted because of the presence of stigma and the anthers at different levels, right? And also, in case sometimes hercogamy doesn't happen, there is a safety mechanism through which pollination can happen. And what is that mechanism? The stigma curls down and touches the anthers. Now what is it promoting? It is promoting a self-pollination. This happens only and only when the cross-pollination fails, right? So hercogamy, through which cross-pollination occurs, if it fails, it has got a self-pollination mechanism through a safety mechanism where there is a curling of stigma happening to touch the anthers and the pollination is promoted. Now let's move ahead and understand about the floral diagram of the ray floret as well. We have seen the bracts as well. So the flowers are bractates and these are zygomorphic. So the florets can be cut into two equal halves only in one plane. So we'll represent that as well. These are exclusively female flowers, isn't it? There is absence of androecium. So they are female flowers. And now coming to the calyx, you can see the presence of calyx in the form of hairy fibrous structures, which is called as pappus. We'll represent that. And now coming to the corolla, we have 3 to 5 in number and they are fused with each other, gamopetalous. Let's represent that as well. And how will you represent that in the floral diagram? We put the brackets over here, isn't it? 3 to 5 in number under the brackets, representing the gamopetalous nature, androecium absent, so androecium 0, and inferior ovary with bicarpellary syncarpous condition, which we are representing here. So that's about the floral formula and the floral diagram of the ray florets. Now, it's difficult to remember all this, isn't it? So now when you want to remember something, it is very easy to jot down the points in a tabular form and remember it. Right? Now, let's understand that as well. We'll put the differences together so that we will revise the entire lecture which we have covered so far. Now, let's understand about the differences. Now, here with these differences, we are getting two entire revision of ray floret and disc floret. Now coming to the first one, what is the location? We have got the disc florets are present in the center, whereas ray florets are on the periphery. Now if you remember, I've asked you in the comments, what are the ray florets now? Are they old or are they young, isn't it? So they are present in the periphery. Let me know in the comments what are they. And now coming to the bracts, they are present for both disc and ray florets. We have also seen in the image under the microscope. This is bisexual, isn't it? Andrecium and gynoecium both are present in disc floret, whereas in ray florets they are only female. The andrecium is absent in that case. Calyx is pappus in both of these. The hairy fibrous structure which you have seen in case of corolla, this is a gamopetalous nature where there are 5 petals which are fused and they are tubular in structure. Now coming to the ray floret, they are 3 to 5 in number, again fused, but the shape differs here. They are tongue-like, which is nothing but ligulate and looking like beautiful sun rays, right? Now coming to the andrecium, it's present, isn't it? There were 5 stamens which we have seen clearly. And we understood about the epipetalous nature as well. The filaments were joining to the petals. They were fusing with the petals, isn't it? And syngenesious condition where the bilobed dithecous anthers were all joining. That condition is called as the syngenesious condition, and tetrasporangiate. So there are bilobe, 2 lobes. So again we will be finding dithecous bilobed anthers with 4 sporangia. Hence tetrasporangiate condition. And clearly it's absent in case of the ray floret. They are female flowers exclusively. And coming to the gynoecium, there were 2 carpels we have seen. The carpels were fused, right? Hence in carpus there's only one chamber, one locule. So unilocular inferior ovary, and the stigma was bifid, which we have seen the stigma clearly, right? The same appears here as well in the ray floret. We have the same condition of the gynoecium. Coming to the pollination, mostly we have cross-pollination happening in the disc florets. We have seen hercogamy, isn't it, for cross-pollination. We understood about hercogamy, which means clearly that the stigma and anthers are in different levels promoting cross-pollination. Now, when that fails, we have got a safety mechanism through which self-pollination happens. The stigma is going to curl down, touch the anthers, and self-pollination happens. Here in this case of ray florets, there's no andrecium, no question of self-pollination, only and only cross-pollination happens here. Now, moving ahead, we understood about the differences, right? Now, let us also understand about the unique characters in the Asteraceae. Now, firstly, involucre of bracts, which you have seen in the side view of the flower, isn't it? You have seen when you have seen the sunflower, there was a whorl of green bracts, isn't it? I told you that they were confused to be sepals, but it's not to be confused with sepals, they are bracts. A whorl of bracts called as involucre of bracts present only in the Asteraceae. Calyx in the form of pappus, the hairy fibrous structure helping in seed dispersal. And coming to the inflorescence, it is called as head or capitulum, only and only in Asteraceae you find that. And 2 types of florets in one inflorescence, isn't it? This is something really unique for any inflorescence. Usually it contains only one kind of flower or a floret. Here we have got 2 types of it, which is disc and ray florets, right? Now coming to it, the name itself, Asteraceae, which is nothing but star-like. Aster meaning star-like. It is star-like inflorescence, hence the name Asteraceae. Now moving to disc floret, we have got andrecium, which is both epipetalous and syngenesious. This is again something unique here. Epipetalous nature, filaments attached to the petals, and also syngenesious conditions, anthers are fused. This happens only in Asteraceae. And now coming to the ray florets, the ligulate or tongue-like, isn't it? Tongue-like or ligulate petals in ray florets. This is again present here only. Now moving to the ovary, ovary is inferior only in Asteraceae. In rest all the plant families which you have in the syllabus, they are superior ovaries. Yes. Now also let's understand the economic importance with one beautiful picture with which you can visualize all the examples together so that you will not have to memorize a song or a dialogue for remembering the economic importance. So here we go. Now here you can see a beautiful picture which you can memorize so that you can remember all the examples and the economic importance in Asteraceae. So what you are seeing here is a grandfather and a grandchild, right? So you can see this man clearly is working in the field of safflower plants, right? And also you can observe that he's sneezing. Why? Because of the presence of the flower of the plants Parthenium, right? So this man is allergic to Parthenium, so that is also clear here. And this field also has got the plants called as pyrethrum. Now these are mosquito repellent in nature, hence you can see the mosquitoes getting repelled away. Yes, the girl is wearing sunflowers right on the dress. Also she is having chicory, applying bringraj oil. Yes, and she is having lettuce. And also you can see that these hens are feeding on marigold flowers, right? Now with this one picture, what are all we covering? Let's understand. So sunflowers on the dress, safflower field, pyrethrum here, the mosquito repellent, lettuce she is having, chicory she is having, Parthenium, the allergic plant for the man, and we have Carthamus and Tagetes, which are producing red and yellow dye respectively. And also one fun fact for you, these marigold flowers usually are given for the hens to enhance the color of the yolk. Why? Again, it is again used in the dye production, right? So with this one picture, we are covering all the examples. So always remember to visualize whatever you study so that you can memorize it in your examinations and score well. So don't forget to subscribe to us for more such interesting and simplified content. Thank you so much, and do click the bell icon so that you would be notified very quickly as soon as we upload another simplified episode. Thank you so much.